Kylie Smith, come to the office, please. Also, Lucas Renaissance, Holden Larson, Dalton Haw, Mara Anderson, Reese Smith, Harley Borland, Caitlin Miller, Sadie Ullman, Ethan Wilson, Alan Mullis, Brady
You have a book cover on?
Yep.
Good.
Nicole Upline.
Book cover, guys? Get them?
I'm pretty much solidly back. I don't have a prep, so. I have it for serious. I literally just don't have a prep.
Book cover?
I want to have a chance to get a look at it.
Alright. Ben, book cover?
What?
Book cover?
Oh, yeah.
Make sure you have your book covers on. Make sure you got them. Alan, make my moves and show me that later time.
Otherwise, I thought we had more for your first today. What?
I don't feel very confident.
Yeah, looks nice. Mine looks awful. My hair looks awful. It looks really bad.
Bill showed me this website yesterday.
Yeah, you still. Where it gives you all the answers.
Yeah, I forgot what it was called though.
Oh,
It gives you like step by step,
Yeah, I know.
like how to do it.
Alright.
I'll have to ask them to send me that.
Okay. Homework will be due here in a little bit. I'll be collecting them if you haven't already turned them in. So, perfect. Names on it, all that good stuff. Alright, good. Names on it. Name. Loop. And there we go. Perfect. Good. Very good. Good deal, good deal. Alright, perfect. Alright, now, just a reminder, when I hand them back, you can always make fixes, changes. I know I handed back some homework yesterday. Who's gone yesterday, for sure? Was anyone in this room gone? I think we had a full class. Okay, so. Remember, because the homework I hand back, you can always redo, just make fixes on a separate sheet of paper, staple it to it, and turn it back in. So some people take advantage of that, some people don't, so I'd truly recommend it for everyone. Let's see, I don't know if anyone really did that yesterday, let's see. Maybe some people turned in. Let's see, 31, 18, 31, alright, good. Some people turned in page 31 yesterday, which is fine. Okay, book covers. So I'm going to ask you to hold up your book. That's all I'm going to ask you to do. I'll give you 10 points for everybody in the room. It'll be pretty straightforward, pretty easy. So hold on, let me get the marks here and let's... Okay, hold up your book. See who doesn't have the cover on it. Oh, look at that, 100%, all 10's good. See, that's all easy to do. You just got 10 points. Good work. All right. Let's see how many people actually don't get that today. So. All right, today we're just gonna take notes. That's it. Easy notes today. The first thing I do want to talk about is the actual homework problems. I want to talk about those last few problems because they were challenge questions. 53, 54. I want to see how many people could figure it out. Especially like 47 through 50. I kind of give minimum hints yesterday. I was very blunt. I was very minimum hints because I want to see who could figure out how to do it without me having to tell them exactly what to do. So what I always recommended people to do is draw it. I mean, that was the easiest way to do those problems. So I'm just going to make up a problem. So the last couple said, okay, B is the midpoint of AC. Okay, that was the hint. And what you had to do is you had to find the missing coordinate. You're probably thinking this is goofy. Why, Mr. Ward, are you talking about it now when you already had the homework due? Because those were challenge questions. I want to see who could figure it out without me telling them explicitly every single answer, how to do every single problem. Because that's what I want to see. I want to see how many people could put it together, how many people had the capacity to actually figure this out. So the idea was that they're going to give you two coordinates. So let's say they give you A is 1, 2, and B is 3, 4. Okay, let's say that those are my coordinates. So the one I'm missing is letter C. That's the one I'm missing. So what you have to realize is in the instructions they said B is the middle. So when you draw a rough picture of this, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Alright, so the idea is that 1, 2, there's letter A, B is 3, 4, here's B, and so that means C has to be over here somewhere. That's the idea. Because when you actually draw the segment, C is on the other side. It's A and C, and B is the middle of it. That's what you had to think about. So you had to find that coordinate. One of the ways you could do it, like I said, drawing it, because that's kind of what I always recommended, is just to count over and up. And that should get you to each spot. It's like slope. That's what you're doing, right? So what I'm doing is when I go over to get to 3, 4, 3, 4 is going over 2, and then up, I had to get to 4, right? So I had to go up 2 more, so over 2, up 2. So from this coordinate, all I have to do is go over 2, up 2. So if I go over 2, that's adding 2 to this number, and going up 2, that makes 6. I don't even need to look at the picture. I can look at just what the numbers were for slope and then just add them to these, or subtract them from those. You're going back. The big thing I'm checking for is how many people can give me the correct coordinate in the correct order. Okay, what I mean by that is some people they give me the up and down number first. That's the y-axis number, that's second number. Okay, so that's the idea. Alright, but it was just a challenge question. Those are the ones I want to see how many people could figure those out. Okay, how many people could find that missing coordinate on those. Okay, the second part was I think 53, 54. I said those were challenge questions. Those problems, they gave you, I believe they gave you on those, you have F to G, or something like that, and M is the middle, correct? It was something like that. And they said, FM here is a 3x plus 4, and this thing over here, this is a 5x minus 10, let's say. That type of thing. Well, if that's the case, and M is the middle, and these, let me label those a little bit better. Those are the variables that they give you. Well, what does it mean if that M is the middle? What does that mean? It's the midpoint. What does that mean? Anyone know what midpoint actually means? The true definition of it? Other than just being in the middle? It means the two sticks are equal to each other. This stick is literally equal to that stick. It's common sense. If M is the middle, like the perfect middle, that means the two sticks have to be the exact same size because it's in the middle of them. They're balanced. So all you have to do is set these two things equal to each other. And then solve. It's like an algebra 1 problem. You just solve this out. So what I would do is I would subtract the 5x over. So 3x minus the 5x. Subtract the 4 this way. So we have the negative 10, we're going to subtract 4 more. So this turns out to be negative 2x equals a negative 14. And then how do I solve that?
Divide the negative.
Divide by negative 2. If I divide by the negative 2, across, you get a positive 7. Okay, then I think what they asked for is, what is the length of F to G? And that was like that was I think number 53 or something like that. How long is FG? How long is the stick? Well, that means I have to plug the 7 back here. So I'm going to plug the 7 here, so it's 3 times 7, and I'm going to add 4. And this turns out to be 21 plus 4, which is 25. So this stick is 25. Well, guess what the other one would be then? 25. You don't need to plug it in. It's 25. It's the same stick. So the whole stick is 50. That's the idea. I didn't give any hints on those. I gave you nothing. Some of you, I just told you, like, figure it out. Like, I was very blunt. Because I want to see who could piece those together without me instructing you how to do it. It's one of those challenge questions. It's the ones that I don't count against your grade, but I want to see who could figure it out for the first time. Who are those kids that have pretty good deductive reasoning and inductive reasoning? Okay? The problems I will be checking for sure for grade. I'm checking 13 through 16, 22 through 27, and 33 through 36. And I believe 40 through 46. I think those are the ones that I know I'm checking for sure. The 47 through 50 and the 53, 54, those are the ones I know I didn't talk about in class. I don't check those for grades. Does that make sense? I'll probably mark on your paper like, ooh, you missed that one, ooh, you missed this one, but it won't count against the score at the top. So when you check your homework, don't like be stressed. Because I know some people like, they were in here this morning, they're just like panicking. They're in panic mode. I could just tell. See, she's in like panic mode. So don't sweat. I said, they're challenge questions. I want to see who could figure it out. Okay? Does that make you feel a little bit better now? A little bit? I just want to see. Alright, let's move on. And don't tell the other classes, because I want to see them panic for a while today. So, because I know they're going to come in here all, he's worried I didn't get it done. So, I want to see who can figure it out. Okay. Let's go on to the new stuff here today. We have to talk about angles today. So we're on section 1.4. 1.4. We need to finish up our topic about angles. This will be the last day of angles. Tomorrow we'll have maybe a work day where we work on some stuff and the homework will be due sometime next week, something like that. So I'll give you the weekend to kind of work on it. But today is just notes, easy notes, because no, we're not in here very long. So, all right, main topic today that I want to discuss. I want to talk about standard position today. That's one of our main topics. What that is, it's a way of drawing angles. That's all it is. It's a big fancy term for drawing angles. Now you're probably wondering, okay, I know how to draw angles. We worked on them yesterday. Yes. But this idea, this concept, helps that everyone in this room draws the exact same picture. Like, there's no difference. What I mean by difference, like when I'm looking at problems and I'm looking at your homework, you know, if I told you to draw a 30-degree angle and I give you a protractor and you could do it, I would have angles drawn every which way on the paper. And angles would be facing other directions, you know, all this crazy stuff. They'd all be, you know, 30 degrees, whatever it needs to be. But the problem is they'd all be facing different directions. Okay? Standard position helps it so that everyone's picture is exactly the same picture. They look identical to each other. So it's just this little, like, it's like a form of drawing an angle so that we all get the same. Okay? So that's the idea. Okay, now what that's going to lead us into is going to lead us into a couple vocab terms. Okay? The terms that we're going to talk about, initial and terminal. Those are two vocab words that go with this standard position idea. It helps you to draw, and I'll explain what those two terms mean, what they mean for our purpose today. Okay, then, once we get through those, then our next topic will be the classifications. The different classifications of angles. The reason why, standard position will help explain why we have certain positions and why certain ones are described the way that they are. Okay, so we'll get to those. There's 5 classifications. I think we hinted at the 3 yesterday, the 3 main ones. But we're going to try to get through the rest of the 5. And then our goal in the very end here, once we're all done with all of this, is to do just a few examples and look at a protractor. So we're going to look at the actual tool that's involved with angles, which is the protractor. That's the idea. Okay? I don't know how far we'll get past that. but this is our kind of our main stuff today. Make sense? Okay, let's jump right into it. Let's jump right into standard position. Okay, alright. Standard position, like I hinted before, is a way of drawing an angle in a very certain spot. So what I mean by that is if I was going to ask you to draw a small angle, this is how it works. You first start by putting the first ray down, and I want you to draw it horizontally to you, going to the right, going towards your right hand. So it's got to be flat against you. This side is called the initial side. It's the initial ray. It's how you start. That's how I always want you to draw your angles. Now I know the book can put angles anywhere they want on paper, but when you have to draw one in specific, so they say draw a 30 degree, draw a 50 degree, draw a 170 degree angle. This is how you should start it every single time. It should be facing to the right, horizontal. Then what you do is you open up counterclockwise. So you're going to open up this direction counterclockwise. And you're going to end with the particular wall, whatever angle you need to finish at. Maybe you're going to go this direction. This side is called the terminal side. And the terminal side, again, is a ray, but it's where you're ending it. That's standard position. Now, I know that seems pretty straightforward, but it has huge implications. Like the way you draw this actually explains why angles and quadrants and all this other stuff works the way they do. Okay, so this is the way I want us to draw angles from now on. Does that make sense to everyone? Okay, now remember from yesterday how we draw or how we label angles. If I put letters on here, you use those letters, or if I put numbers on the inside, you use those numbers. So if I label this angle A, B, C, with those there, what's the most important letter of those? B. The vertex, where the two rays meet, right where the angle's actually formed, the two endpoints. This is called a vertex, the spot. So we talked about yesterday. It is the most important letter. Since this picture is very simple looking, you could call this angle B. Draw a mock picture, put the letter in front. We could call this angle ABC, or angle CBA. But guess what's the middle? It's always B. B has to be the middle letter, because that's where your vertex is. Okay, now when we talk about this type of situation, we always talk about the smaller angle, not the outside. That's just what we, that's just normally what we do. Okay, and then if I put a number on the inside, we could call it whatever number you want. So if I call this angle number 2, fine, you could call that angle 2. Any questions with any of the stuff we talked about yesterday? Perfect. Okay, now, let's talk about how this leads us into classifications. Like, why do we have this? Because it seems silly. Because everyone can draw pictures. It doesn't really matter the direction you face. It makes it easier to look at, so everyone has the same picture. So when you're looking over at your neighbor's work, trying to figure out what they're doing, it looks like yours. There's no difference in the actual diagram itself. But it actually leads into some basic vocab terms. So let's talk about what we did here earlier. What is this object? What do we call that again? We've had it since algebra class. What do you say it again? Coordinate plane. Yeah, plane graph. What do you want to call it? XY graph, XY plane. I don't care. It's the coordinate graph. This object is labeled in such a way that it actually came from this. So let me explain. When we draw angles in standard position, the vertex is right on the origin. The vertex is right there. The initial side goes along the x-axis. This is the initial side, because that's the first thing you start with. You always start with x-axis numbers. So it makes sense. The initial is the x's we start with. Then you open up counterclockwise, right? You open up this way, and you get to your terminal side. That's pretty straightforward. Now, here's the thing. where is this on the graph? What do we call this general area? What do you call the area in the upper right corner? What, say it? One. One what?
Quadrant.
Quadrant, right? The first quadrant, right? Quadrant number 1. Okay, we number them with Roman numerals, right? That's quadrant 1, we call it a Roman numeral. Anyone know why we call that quadrant 1? Why do we start there? Because that's where your angles will be first. When you open up counterclockwise, it'll be the first quadrant you hit. Because now, when I keep opening up my angle, because I had the terminal side, but let's imagine that I started the initial side and I kept opening until I got to over here. What quadrant is this called? 2. And that always causes a problem with a lot of people in algebra class. They're always like, why is that 2? It's stupid. Why isn't it the bottom? Why isn't it like a clock? It's like that because what angle would you hit next? You would hit that quadrant when you keep opening. That's why they numbered it 2. They literally numbered it counterclockwise because of this. That's why they numbered it 1, 2, and eventually you'd hit quadrant 3 and 4. That's why they did it. A lot of people don't know that. They just think, oh, it's stupid, they're just trying to mess with you. No, it's for reasons because of angles and geometry. That's why they numbered it counterclockwise. Now, if you go to a foreign country, they number them differently. So it's just, that's their personal preference. This is how the US does it because it's based on angles. That's why it works. Okay, now, everyone comfortable with the way we draw angles on a quadrant system, that type of thing? You don't need, when you draw angles, you don't need to draw the quadrant system. I just want you to realize there is a relationship here to there. Now, the reason why I bring this up is obviously to talk about the quadrant numbers, because a lot of people don't understand why they're counterclockwise because of this. And number 2, talking about the actual classifications, how they're named. Okay? How they're named. So, let's go back to this angle. This type of angle has a classification. It's a type of angle. Would you agree that that angle right there, that black angle, is small? Agree? Mm-hmm. So what classification would it be called? Acute, right? That was the word we used. Okay, so classifications. First one is called acute. Now again, the way I describe it is, I know it's silly, but it works for me, I always remember it. I think of acute as small. Things that are cute are like puppies and kitties, they're small. That's how I think of it, so acute. I know it's silly, it's stupid, it helps me remember it. So acute, small. These are angles that are from like 0 degrees up to 89 degrees, and any decimal in that area. So like 89.9, I'm fine with that. Those are acute angles. Okay, so this angle I have there, it's acute, right? It's 0 up to 89. Now, when I get to the second category, is when I hit exactly 90 degrees. So the terminal side is right here. The terminal side is right on the y-axis. Now, that is also called a quadrantal angle. Let me put that on there. Quadrantal angle. A quadrantal angle is an angle where the terminal side and the initial side land right on a major axis. X-axis, y-axis, that type of thing. There's many quadrantal angles, but that's the idea. Okay, so quadrantal angle. Now this is the 90-degree angle. Now, what does everyone know for a 90-degree angle? What do I need to put right here?
Square.
A little square, right? Everyone knows it. You put a little box, it means it's exactly 90. If your pictures don't have a little box, we cannot assume it's 90. It might be close, but it may not be exact. Anyone know why they put a little box in the corner? Because what picture are you looking at right now? What is that object behind it? What's the red object? What did we say earlier? Coordinate plane. Well, this, in a coordinate plane, this would be the 1 by 1 box, right? It's literally a square in the corner. It's the 1 by 1 box. A lot of people don't know that. They always think, oh, because you could fit a square there. You could put a little box and it'd fit perfectly. No, it's because of the coordinate plane. It's literally the 1 by 1 box that sits there perfectly. That's why they have it. Okay, that's why they put the little box there. It signifies the actual coordinate plane in the background. A lot of people don't see that. Okay, so that's why they put 90s. Now, we have a name for a 90-degree angle. Starts with an R. Right angles. That's exactly 90 degrees. Now, there's a bunch of different names for a right angle. I know there is. One of the words that we use for right angles in this class, perpendicular. That's one of the words we use. Not parallel, but perpendicular means 90. And if you're in drafting or woods, or design of some type, they might say it's flush. It's flush. Means it's like right up against each other. They're perfect L shape. But a word that you'll get into like a college level geometry class is orthogonal. Orthogonal. That means it to be 90 degrees. Not particularly sure if your book uses that at any point. I know that my pre-calc textbook does. So, I mean, you just gotta get familiar with that term. It means 90 degrees. Most of the words that we use in this class are perpendicular right. I use those a lot. Okay. Are we comfortable so far? You got a basic understanding? Alright. And now if we kept opening, and we open up the angle so it's now bigger to here, so now the terminal side is here. And we're in the second quadrant. What type of angle is that now? Yeah, it's really big, right? So that angle is obtuse. That is anything from 91 degrees, and decimals around there, up to 179 degrees, and any decimals around there. So it could be like 90.2 degrees, all the way up to 179.9, something like that, just in that general ballpark. Okay, because you could have decimals. That's obtuse. How I think of obtuse, like obese, big, has the same OB in the front. Obtuse is big. Okay. Those are pretty easy to spot. The problem, I don't know why, for some people, they look at this picture and they go, okay, it's big, it's obtuse. But the minute I make a triangle like this, they can't see that the triangle's obtuse anymore. The angle's big. It's bigger than, if you're like, turn your head upside down, it's bigger than 90, okay? If I were to flip this thing around, it'd look like this. Do you see the obtuse angle now? For some reason, people can't see it unless you draw it exactly like that. I don't know why, it's a weird, quirky thing. Okay, it's just, because remember, you can always turn your book. Like, you have the luxury of, like, turning it to actually look at it at different angles. Sometimes that helps you identify what type of angles you have inside the pictures. Alright, any questions with the third type? Okay, fourth type today. Is a straight angle. Straight angle, and that would be this. That's a straight angle. What would a straight angle be in terms of measurement?
180.
Exactly 180. It's turning all the way around, right? 180 degrees. That's a straight angle. Exactly 180. So it's going from here, just turning around, facing the other direction. There's another name for a straight angle. We can call it a quadrantal angle, just like the 90, right? It landed on a major axis. Do you agree that the terminal side landed on an axis, landed on the x-axis again? There's another name for it. They're actually called opposite rays. So, again, it could be called a quadrantal angle or opposite rays. And let me explain this concept of what an opposite ray is. If you draw a ray going this way, so there's a ray, I'll call this AB. An opposite ray starts at the same endpoint but goes the other direction. So ray AB, its opposite is A to C. These are opposites of each other. Because one goes this way, the other one goes that way. Notice, why can I write it like that? It looks goofy, right? Most people go, didn't you draw the arrow the wrong way? Because the picture's going the other way. This is notation. Notation doesn't have to look like the picture. Where did the arrow pass through? What letter did it pass through? C. That's why the arrow has to be passing through C. The endpoint's above A. That's where the endpoint was. Okay? Some people really struggle with that when they're trying to look at opposites. They don't understand that you can write them like this. These are opposite rays. They go down. They go different directions. That makes exactly 180 degrees. All right, now those are the four types. How many people know the four types there? Like you've seen them before, all four of them? Okay, that's what I figured. The fifth one, and I said it yesterday in class, and I had a lot of people just kind of go, they looked up at me because they just never heard this word before. It's called a reflex angle. So number 5 is a reflex angle. That's your final fifth type. Reflex angle is when you go past 180 degrees. You go past it. So the reflex angle would tend to look something like, let me draw the original here. Okay? The reflex angle would look something like this. It goes past 180 degrees. Okay, so that might be like a 210 degree angle, let's say. It can be anything from like 180.2 up to 360. 360 is going all the way around, like spinning all the way back. So it can be anywhere in this range, up to here. So that's the idea. Those are reflex angles. So in fact, it's like 181-ish in that area, all the way up to about 359. As you get to 360, you came all the way back to 0 again. Okay, so that's a reflex angle. Now why they call it a reflex? It's kind of based on anatomy, really. This is just a demonstration, so I want everyone to hold out their arms straight in front of them. Hold it out straight as you can, right? Some people have this weird thing, like especially, it's usually in women, unless you have really good flexibility. They can like push their arm further past straight. Can you even do that? Where it goes further past straight? So most girls can do that. Oh my gosh, Trinity's got it. Because she can see her arm goes like past straight. Go the other arm. The other arm is really good. Yeah, so she has really good flexibility. That's a really good thing for strength. A lot of people don't realize that. If you have really good flexibility, you're actually really strong. That's how it works. The idea is that that's not normal. I'm just saying it's like certain people can do it. It's usually women. Some guys can't if they've really worked on flexibility and stuff. But it's reflex. If most normal people that can't do that, like I can't. My arm doesn't look like I can get that far. If my arm were to do that, they call it a hyperextension, right? It goes past the normal point. It really hurts you, tear ligaments and stuff for most people. But your body's natural reaction is to reflex, is to pull it back in. That's why they call it a reflex. You're going past straight. That's the idea. It's anatomy. Okay? All right. That'll help you out like a visual. That was really good though. So, all right. Okay, we good with the basic terms, classifications. Okay, now I know we only have like a minute or two. Tomorrow, we're gonna really work on like looking at protractors. How do we measure angles? So if you have a protractor at home, that's the thing with all the numbers from like 1 to 80, or 0 to 180. You can bring one of those in. I have a couple examples I'll let you borrow when you're in class here. They're just see-through, pretty easy. But if you have a protractor, definitely bring it in tomorrow because I'll show you kind of what we can do. Okay? All right, but we're done for the day.